Hi guys, this goes with Chapter 15, Section 2. The title for these notes is Energy in the Atmosphere. So here we go. First thing you need to know, there are three different types of heat transfer. Now heat transfer means that heat is going from one object to another. So our three types are radiation, thermal conduction, and convection. So radiation is heat that you feel without actually touching the object. So if I took my hand and stuck it next to a light bulb, not touching it, but just put it near it, I would actually feel the heat coming off the light bulb, and eventually my hand would warm up. So that's radiation. I'm feeling the heat coming off of something without actually touching it. Number two, thermal conduction. This is when you are actually touching another object. So the heat travels from object to object through direct touching. So this would be like if I actually touched the light bulb that was hot. Since the light bulb was hot, then my finger would get hot from the light bulb, and it possibly would burn it. Number three, convection. We've talked about this a couple of times so far. We talked about it in the mantle when the hot rock is rising and the cool rock is falling. We've talked about it in ocean currents when we talked about deep currents. The cold water falls, the hot water rises. So it also exists in the atmosphere. Hot air rises, cool air falls. So all three of those things create convection currents. So convection means anytime you have something hot that's rising and something cool that's falling. And it creates that circular motion. Now, you've already taken notes on the layers of the atmosphere, so hopefully you know that the troposphere is the lowest layer of the atmosphere near the ground. It happens to be where we live, and it also happens to be where weather takes place. So these three types of heat transfer work together to heat the troposphere and keep us comfortable. This is a diagram that shows you how it heats the troposphere. So we have the sun that gives off radiation. Remember, radiation is when you're not actually touching it, but you can feel the heat coming off of it. So the sun heats the earth. Okay, we get energy from the sun. It comes down, hits the ground. When it hits the ground through radiation, it warms the ground. Now the air is right near the ground, touching the ground. So because the ground is warm, through conduction, it's going to heat the air that's touching the ground. That heated air is going to start to rise. That is convection. So the hot air goes up. All right, so we have 5 examples here. So I want you to pause this video and see if you can come up with the answers on whether these are convection, conduction, or radiation. And we'll go over the answers in just a minute. All right, so number 1, your feet get hot when walking barefoot across hot pavement. So your feet are actually touching the hot pavement, so that's got to be conduction because that's object touching object. Number 2, you can feel the heat from the hot iron without touching it. So if you put your hand close to it, you don't touch it, but you can still feel the heat coming off of it. That's radiation. Number 3, in winter, the second floor of your house is warmer than the first floor. So the heat has risen up through your house. So because the hot air has risen and gone up, that has to be convection. Number 4, you are lying on the beach and the sun makes your skin tingle. You're not actually touching the sun and there is no heat that's rising there. So that has to be radiation, where you're feeling the heat without touching the object. And number 5, you burn your finger when you accidentally touch the stove. You're physically touching the hot stove, so that has to be conduction, where object is touching object. The greenhouse effect. So we get energy from the sun. It comes to the Earth's surface, we just saw, as radiation, and it heats the Earth's surface. Now, heat energy is different than the radiation energy. Radiation can pass through the atmosphere, and thermal heat, which is the heat you feel, can't always get out of the atmosphere. So it holds the heat in, the atmosphere does, and makes the atmosphere act like a blanket. So it keeps us warm. Now, not all that heat stays in the atmosphere. Some of it does escape, but enough of it stays in that it helps regulate our temperatures and keep us from getting too cold at night and too hot during the day, which makes Earth the perfect place for us to live. So why is it called the greenhouse effect? Well, because a greenhouse is designed to do that, where it takes the energy from the sun, it goes through the glass, and when it warms up the plants and the soil that are inside the greenhouse and turns to that thermal heat can't escape back out through the window, so it gets held in. It's a lot like in the summertime, if you open up a car door that's been sealed all day long, the inside of the car is really, really hot because the radiation from the sun has come in through the windows, and when it turns to heat, when it heats up the seats, that heat can't get back out. That's why that temperature of the car is so much warmer on the inside. Here's a diagram that shows you how it works. So we have the energy from the sun coming in as radiation. Some of it escapes back into space, but a lot of it gets held in. You can see the atmosphere there. It's trapping the heat in, and it's acting like a blanket to keep us warm. Alright guys, so that's it. So make sure you have your notes filled in and bring them to class tomorrow.